Hello, students. Acids and bases are perhaps among the first names that you hear while entering the chemistry world. Right from the early years of our life, when we were little children, we have heard about chemicals and chemical reactions. We know that too, chemicals mix to form something you regularly use. Lemons, soda, soaps, baking soda, and whatnot. All of these make use of acids and bases so much in our everyday life. Let's have a deeper understanding of acid and base by discussing the theory which was proposed. First is the Arrhenius Theory, second is the Bronsted-Lowry Theory, and lastly, the Lewis Theory. First is Arrhenius Theory. Arrhenius acids are those acids that increase the concentration of H plus ions in their aqueous state. A substance qualifies as an acid if it ionizes in water to furnish H plus ions, thereby increasing the concentration of H plus in the solution. In the same way, an alkali ionizes to furnish OH minus ions in the aqueous solution, thereby increasing the concentration of OH minus in the solution. For example, HCl, when is dissolved in water, produces H+, which being unstable, goes and reacts with another water molecule to form hydronium ion, and the chloride ion is released. Similar is the case with sulfuric acid, which can lose both its H+ stepwise, forming HSO4- and SO42-. Likewise, when NaOH is dissolved in water, it releases OH- and Na+, and CaOH twice forms CaOH+, when it releases one OH-, while forms Ca2+, when it releases the second OH-. Next is the neutralization reaction according to the Arrhenius theory. This can be explained as acid releases H+, and base releases OH- to form water, and remaining ions combine to form a salt. Finally, in this theory, we will see the limitation of the theory, which are as follows. It fails to explain the acidic nature of substances like CO2, SO2, SO3, etc., which do not have hydrogen. Similarly, it also fails to explain the basic nature of substances like NH3, CaO, MgO, etc., which do not have OH group. It fails to explain the acidic and basic behavior of substances in solvents other than water, such as ammonia, alcohol, etc. The theory fails to explain why strong electrolytes like nitric acid, that is, HNO3, are completely ionized in an aqueous solution, whereas weak electrolytes like acetic acid, that is, CH3COOH, are ionized to a small extent only. Next is Bronsted-Lowry theory. According to this theory, acids or bases are based on H+ transfer. Acids are those substances that can donate H+ ion, and bases are those which can accept H+ ion. Now, let us see the neutralization reaction. According to the Bronsted-Lowry theory, the acid gives its H+ to the OH- of base to form water, and the remaining ions combine with each other to form a salt. Next, Bronsted-Lowry theory also explained amphoteric substances. These are the substances that act as both acids as well as bases, according to the situation. Water is a good example of this, as it can accept H+ and form hydronium ions, and can also lose it to form OH-. Other examples, which are not that prominent, are HSO4-, which easily loses H+ to form SO4 to minus, while it can't easily accept H plus to form H2SO4. Likewise, ammonia can easily accept H plus and form an H4 plus, but can't lose H plus that easily to form an H2 minus. Let us now see the limitations of Bronsted-Lowry theory. Bronsted-Lowry theory cannot explain the reactions between acidic oxides with a base, like SO3, CO2, SO2 and many more, and also the basic oxides with an acid, like CaO, BaO, NGO and many more. It cannot explain the reactions occurring in the non-protonic solvents. Acid-base reaction in the non-aqueous medium cannot be explained. The Lewis concept is also very similar to the Bronsted-Lowry concept. The only difference in them is the fact that the transfer of lone pair of electrons is taken as the criteria here. The Lewis acids are those which can accept a lone pair of electrons. The necessary condition for Lewis acids is the presence of a vacant orbital, while that for Lewis base is the presence of lone pair. Before giving an example, we need to understand two terms: central atom and lone pair. The central atom is the one that is combined with all other, or maximum atoms in a covalent compound. The lone pair is the valence shell electrons, which doesn't take part in bond formation. For example, ammonia. In this, N is attached to 3 hydrogen, which makes it the central atom. Also, in nitrogen, out of the 5 valence electrons, 3 are involved in bond formation, while 2 electrons remain unbonded. These 2 electrons together form a lone pair. An example of Lewis base is ammonia, which has 1 lone pair on the central atom. An example of Lewis acid is BF3, which has a vacant orbital to acquire the lone pair. According to Lewis theory, the neutralization reaction is when the OH present in the base donates its lone pair to H in the acid, forming water molecule, and the remaining ions combine with each other to form salt. Now, if we see the limitations of the Lewis theory, they are: Lewis theory does not explain the relative strengths of acids and bases. Lewis theory provides a general idea, which involves all the coordination compounds and coordination reactions, which is not always true. The concept does not explain the well-known protonic acids' behavior, such as HCl, H2SO4, etc., which does not form the coordination bonds with bases. Hence, according to Lewis, those are not considered acids. Let us summarize. We learned 3 theories that define acids and bases in the following manner. As per Arrhenius, acid releases H plus in an aqueous medium, while base releases OH minus in an aqueous medium. Bronsted-Lowry theory, acid is H plus donor, and base is H plus acceptor, while the Lewis acid is lone pair acceptor, and the base is lone pair donor.